Okay, in lesson 2.1, we're going to plot points associated with ordered pairs of numbers. We're going to determine whether an ordered pair of numbers is a solution of an equation. We're going to graph both linear and nonlinear equations using tables. So before we begin that, we need to talk about some basic parts of our coordinate plane, or our XY axis, as some people call it. Okay, so some of the parts are this axis right here that is horizontal. You can see the little X right here. Sometimes that's written and sometimes it's not, but this axis that runs this way, this is your X axis, is also your horizontal axis because it runs horizontally. Okay, this axis, you can see the little Y right here, the one that runs up and down. This is your Y axis. It's also your vertical axis because it runs up and down. Okay, the origin, which is another thing we need to talk about, is the point right in the middle. Okay, it's the point 0, 0. That's where X is 0 and Y is 0. That's our origin. So we've talked about the origin, x-axis, y-axis, quadrant 1, quadrant 2, quadrant 3, quadrant 4. The vertical axis and horizontal axis, we talked about those. So your ordered pair is always going to be x and y. X is always going to be in the front, y is always going to be second. So in the first quadrant, x and y are going to be positive. In the second quadrant, x is going to be negative, y is going to be positive. The third quadrant, x and y are both negative. And in the fourth quadrant, x is positive and y is negative. So we've got those, got this. So let's talk about how you plot these points. Okay, I always give the example of walking to an elevator and then either going up or down. So we talked about how this first is always your x, and the second is always y. So if I want to plot this point right here, I'm going to walk to -4. Well, when you're walking, you're going horizontally. So I'm walking, well, there's -5. I'm walking to -4. The next point is a 3. So that's going to be my y. And since it's a positive 3, that means I'm going to go up to 3rd floor. So I've walked to -4, gone up to 3rd floor. That's going to be point A. Okay, to get point B, I'm going to walk to 4. I'm going to walk past 3 all the way to 4. Then it's a -2, so I want to go down in the basement, -2. That's going to be point B. C says walk to -3, so I'm walking to -3, and then it's 0. So that means I'm not going to go up or down. I'm going to stay put, not ride an elevator. So that's C. D says I'm going to walk to 0. 0 is going to be in between -1 and 1, so I'm walking to 0, and then I'm going to go up to 5th floor. That's going to be my point D. Okay, and let's state it to determine whether an ordered pair is a solution of an equation in two variables. We use the first number in the pair to replace the variable that occurs first alphabetically. In a coordinate plane, the first axis is called the x-axis and the second axis is called the y-axis. So I'm going to make a little table here because they want us to show that these pairs are actually solutions to this equation. So when we look at this, we've got some x coordinates and we've got some y coordinates, and we have this equation. So on the first one, they're saying, well, let's check out -4 and 3 and see if it is a solution to this equation, y equals -1/2 x plus 1. Okay, and so what I'm going to do is wherever I see an x, I'm going to plug in -4. Well, I see an x right here. So -4 would go right there. And wherever I see a y, I'm going to plug in 3. And I see a y right here, so I'm going to put a 3. But everything else is going to stay the same. Okay, and then I want to say, well, is this true? Like if I plug this in my calculator or in my brain, is this going to give me an answer that's correct? So 3 is equal to negative 1/2 times negative 4 plus 1. Well, 3 is just 3. There's nothing to be done there. Okay, negative 1/2 times negative 4. If you type that in your calculator or you put that in your brain, a negative times a negative is positive, and half of 4 is 2. And 2 plus 1 is going to give us 3. So yes, that's true. This point is a solution because it works. 3 is equal to 3. So we're going to walk to negative 4. We're going to go up to third floor. We're going to plot that point. That point works. Okay, the next point they want us to use is 0, 1. So we're going to see, so here's 0, 1. Wherever we see x in the equation, we're going to plug in a 0. Wherever we see y, we're going to plug in a 1. So in our equation, x was right here. So I'm going to put a 0 there for x, because we're going back to this original equation. And wherever we see a y, we want to put a 1. Okay, but everything else stays the same. So the equal sign still here, negative 1/2, then plus 1. Now I want to see, is this true? Well, there's nothing to do with the 3, so we're okay with that. Negative 1/2 times 0 is 0, and 0 plus 1 is 1. I'm sorry, hold on one second, let's back that up. I accidentally plugged in a 1 for the y, and it needs to be, I plugged in a 3 and it needs to be a 1, so let's back that up. Okay, so we want to plug in a 1. And so there's nothing to do to the 1, that part's done. Negative 1/2 times 0 is 0, plus 1 is 1. So yes, that works, that's true. So the point 0, 1 is a point on this graph. And if I want to finish this, I can connect these dots and it will fill out the rest of the line. Now, because you're able to use a graphing calculator, you can check your work, especially when it's written like this. Okay, so let's pull up that graphing calculator and see if we can get it to check our work real quick. So I'm going to go to y equals, and let me clear this out just to make sure you know how to type this in. So I hit the y equals button. I'm typing in the equation negative, and then I want a fraction, 1/2. So alpha y equals, enter, 1/2, and then we've got our x. X is right by the alpha button, and then we're supposed to do plus 1. And then enter, and then I'm going to go ahead and look at the graph. The graph is at the top button right underneath your screen, top right. Now, this graph does look very similar to the one we just had. Let me go back here and raise this up just a tad. So when we're looking at this, this line is pretty similar to this line. Now, you do need to know on your calculator, the screen is kind of squished right here and it's wider this way, so it's going to be slightly off. Another thing I want to do is I can also look at my points and make sure that this point, negative 4, 3, and 0, 1 is a solution. And I can do that by saying second graph, and I can look, oh wait, there's negative 4, 3. Another point that's going to be on my graph is negative 3, 5/2, negative 2, 2. Okay. Another one we looked at was 0, 1, and that one's right here. And you can use your arrows to scroll up and down. If I needed to see if negative 20 was 1, I could go all the way back to negative 20 and look and see if that point's on my graph. Okay? So that's kind of how you type that in your calculator. So what happens when we're given a standard form of the linear equation? So this right here, this y equals negative 1/2 x plus 1, that's in this form. Okay, and that form is the slope. We'll talk about this some more, but this is the slope-intercept form. And that form is very nice because that is written where it says y equals, and we can type it in our calculator and find out all kinds of things. if it's not written in slope-intercept form and it's written in this standard form where it doesn't have y equals, we're going to have to work a little bit harder to get this to work. Okay, so here's an example of one that is written in a slope-intercept form. Y equals 2x minus 2. Okay, so they said graph this. So the first thing they did to graph it was they just picked some things. They picked some numbers right here. And it's always good to pick a negative number. It's always good to pick 0, and it's always good to pick another positive number. You really only need 2 numbers in order to do this. But if you pick 3, you can make sure you're not making a mistake somewhere. If you're making a mistake, it's not going to line up perfectly, and you're going to go, oh, wait a minute, I messed up. So how did they get the -4 here? Well, instead of the x, they plugged in -1. So they would have said 2 times -1 minus 2, and they would have gotten the answer as -4, which is what went right here. This -1 came from plugging in the x of -1. They plugged in the -1, and they got an answer of -4. So on this one, they're plugging in 0, so 2 times 0 minus 2. Okay, and then they're getting an answer of -2, which is what they put right here. So they're getting 0, -2. When you plug in 3, 2 times 3 minus 2, they're getting an answer of 4. Okay, and so they've gone and they've plotted these points and they made a perfect line. So these are the points that we're supposed to find on our graph. So if we go back to our graph, it's always a good idea to practice 2x minus 2. Go back to my graphing calculator. I'm going to hit y equals. I'm going to hit clear because I don't want that there. I'm going to type in 2x minus 2. And then I'm going to hit second graph. And I've gone all the way to -16. Okay, but I want to see if -1, -4 is on there. Just to make sure I'm okay. So -1, -4. Sure enough, what about 0, -2, which is this point, and then 3, 4, all there. So we did good with that. Okay, and we could also look at the graph if we just hit graph. Okay, so it says type equation with the y equals key, hit graph, zoom 6 standard, and then second table for points. The only part we didn't do was the zoom 6. And we could talk about that later, but we'll come back to that. So we've got an equation. We're going to graph it by hand first. We're going to pick some points for x. So let's pick -2. Let's put 0. So we picked a negative number. We picked 0. Let's also pick a positive number. Okay, so now the parts we're going to leave everything else alone except for this x right here. So we've got -2, and then we've got an x minus 2, -2x minus 2, and then -2x minus 2. Okay, now these are the numbers that we would plug in for those x's. First time we're plugging in -2. So -2 times -2 is 4 minus 2. 4 minus 2 is 2. So that's going to give us the point. X is -2 and y is +2. So -2, +2 right here. Okay, we're going to plug in a 0. So -2 times 0 is 0. 0 minus 2 is -2. So we're going to get -2. So when we plugged in a 0, we got -2. So 0, -2. And then when we plug in a 2, -2 times 2 is -4. -4 minus 2 is -6. So we would get the point 2, -6. Way down here. Okay, so this would make a straight line. We go back and graph it. We would connect these dots. Okay, and then we could also check it on our graphing calculator to make sure these points -2, 0, -2, and 2, -6 are actually on the graph. So I'm going to go right here. I'm going to go to y equals. I'm going to sew the equation. We want to clear it out. It's this time it is -2, x is the button right beside the alpha button, -2. And we want to do second graph, kind of look and see. Type something in wrong, so hold on a minute. Make sure. I think I accidentally hit the minus instead of the negative. So -2x minus 2, hit graph. That's a mistake a lot of people. If you would say negative, you want to put the negative sign that's down here by the 0 instead of the minus sign. So there's what our graph looks like. Now I want to look at my table, so second graph, and I want to make sure that these points that I said were on it were actually on it. So I had the point -2, 2. So here's -2, 2. We've got the point 0, -2, which is right here, and we've got the point 2, -6. So yes, we're good. They were all there. Okay, so we can check it with our looking at our graph and looking at our table. Okay, here's another one. We've got 5/3 x plus 2. We're supposed to graph that. Okay, so just because I know a little bit of math, I know if I plug something in there that is a multiple of 3, it's going to help me to get this to cancel out. But if you don't know that, because I don't want multiplying something by 5/3 is a lot of times going to give me a decimal. What we could do is go straight to our calculator. Okay, we could go to our calculator. We've got 5/3 x plus 2. So go to y equals. Remember, we want to clear this out. We're typing in a fraction. So alpha, y equals, and enter. So we have 5/3, and then we're multiplying that by x, and then plus 2. And I can look at the graph. That kind of helps me. But one thing that's going to really help me is if I hit second graph, I'm going to find some points. Well, some of these look really nice and some of them don't. Like -6, -8. I mean, that's one that is going to be easy for me to plot. -6, -8. So if I plug in a -6 in this equation, I would have gotten -8 for the answer. Okay. -3, -3. I don't want to do -2, -4/3, because it's going to be hard for me to plot a -4/3. So I'm going to write -3, -3. That was not a bad one. Okay, and then I'm going to kind of, I've got 2 negative points. Let's go and see if we can get some positive numbers. There's 0, 0, 2 would be on there. 3, 7. So I don't know if that's going to be on my graph. I'm going to go ahead and write this down. We had 0, 2, and a 3, 7 was another one that was on there. So 0, 2, and 3, 7. So if we go plot the point, walk to -6, go down to -8. So -6, -8. -3, -3, walk to -3, go down to -3. And I'm counting this. It looks like it's -4, but -1, -2, -3. So I look like I did that wrong. So -1, -2, -3 is going to be right here. This is a little bit misleading over here, this -3. 0, 2. Walk to 0, go up to the second floor. 3, 7. Okay, and you can tell that makes a pretty straight line. So if your teacher could draw correctly, so if your teacher could draw a straight line, that'd look really nice. But we're going to connect the dots. And we're going to plot that. Now, we could do what we just did a while ago and kind of do a self-check. Let's just check this one. So if I plug in a 0 here, 5/3 times 0 plus 2, it should equal 2. And it does. 5/3 times 0 plus 2 is 2. That's how we were doing it up here. So either way will work. Okay, now It gets a little bit more complicated if we have to graph something that is not in standard form. So it says graph a line in standard form. The calculator cannot graph in this form, so it has to say y equals. Now, it's perfectly okay to try to plug things into this, but I would strongly encourage you as the first step of this to get it to say y equals. So in algebra, when we're trying to get it to say y equals, we've got to move things around. So I need y to be by itself. So the first thing I want to do is get this 3x to move to the other side of the equal sign. So I'm going to, since it's a positive 3x, I'm going to subtract 3x. Okay, and we're doing kind of keeping this equal sign lined up. So 3x minus 3x is nothing. Negative 6y is equal to 12 minus 3x. Those are not like terms. They don't go together. So I have to list them separately. 12 minus 3x. We can't do 12 minus 3 is 9. Because these things don't go together. I'm almost there. I need to get rid of this negative 6 in front of the y, so I'm going to divide by negative 6. But I have to divide everything by negative 6. These are going to cancel out because negative 6 divided by negative 6 is 1. 12 divided by negative 6 is negative 2. And negative 3 divided by negative 6 is a positive 1/2 times our x, which we still have there. Okay, so now we're going to go to our calculator. We're going to get some points that we can graph. We need some x and some y values. I'm going to just look for, because this does have a fraction in it, it might be hard to find some that we like, but all we have to do is go to our calculator and type in negative 2 plus 1/2 x. So I'm going to clear out my screen that I had before. And we said negative 2 plus, and we've got a fraction. You could also type in 0.5 for 1/2 if you wanted to. So 1/2, to get that fraction to come up, we did alpha y equals. Okay, and I really don't care what the graph looks like. I just want the table so I can fill out my table that I have. And we didn't pick anything yet. And I don't really want to pick things to go on my table that has fractions. So right off the bat, this 0, negative 2 is kind of hitting me. There's one I could put. 4, 0, that looks nice. It's easy to plot. Okay, I don't want to pick 3, negative 1/2 because that's kind of awkward. So I'm going to go back. There's something nice, negative 2, negative 3. And that's plenty of points to plot. So 0, negative 2. 4, 0, and then negative 2, positive 3. Okay, I stopped that because I realized I must have written down something wrong, and I did. It's negative 2, negative 3, not negative 2, 3. So negative 2, negative 3 is right here, and you can tell that that makes a straight line, so you know you're on the right track. And there's our point. So we graphed our line in standard form. We just picked some things that would be easy for us to plot. Okay, if we want to graph nonlinear equations, we can do the same thing. We're going to practice one of them, but here's your key strokes that you want to make. I'm going to go ahead and get these roughly graphed for you. So this one is done for us. So if we want to graph y equals x squared on the graphing calculator, we're going to go to y equals. I'm going to clear this out, and then you would just do x, and then you can either hit this rooftop and then the 2, or you can hit the x squared button right here that's in your first row. I just get in the habit of doing rooftop because it works for anything, even if it's not squared. Okay, and I can hit graph. We can look at the graph that makes a U that's called a parabola. If I wanted some points to plot, I could do second graph. I could grab some points to fill in for that U. Okay, I think the next one on our list is y equals the absolute value of x. And so I don't know if you guys remember, but if you've got this one, absolute value means if it's positive, it stays positive. If it's negative, it's going to turn to positive. So it's how far is the number from 0? So if we plug in a 0, well, we're going to get back 0. If we plug in a 1, we're going to get back 1 because 1 is 1 away from 0. If we plug in -1, -1 is also 1 away from 0. So we would get a +1. So those points 0, 0, 1, 1, -1, 1, if we kept going with that, it kind of makes the shape of a V. Okay. So when you go to your graphing calculator, go to y equals, how do you get that to come up? Okay, absolute value is actually a couple of places on the calculator, but one place that it is under math. And if you go over to number, this ABS right here stands for absolute value. So that will get it. I'm going to go ahead and just type an X in there and hit second graph so you can get some points on the table. We picked -1, 1, 0, 0, and 1, 1 were the ones we plotted. If we looked at the graph, it makes a V. Okay, I have a really hard time remembering where buttons are on the calculator. So there's also this excellent thing that kind of, if you do, I'm going to clear this out real quick so I can show you. If you do alpha, if you look down here and you see above 0, it says catalog. So if I do second catalog, this gives me everything. Well, absolute value starts with an A, so it's at the beginning. So I could also get it there. So it was under the math button over to number, and it's under absolute value. Okay, so there are some directions down here if you happen to forget. So y equals x to the third. Okay, so if I plug in a 0, let's do 0, -1, and let's do +1. Okay, so I'm going to go to my graphing calculator, and I'm going to clear this out. And we want an x rooftop 3, and I want a table. The numbers I asked that I wanted to find on my table were 0, well 0 is 0. Okay. -1 is -1 here, and +1 is +1 here. So -1, +1. When you graph this, and I do want you to kind of look at the graph so you can kind of see what shape it is. When you hit graph, kind of makes like a snake shape. So 1, 1, because if you just plot these points, you're not going to see that. So it kind of does something similar to a snake when you have an x to the third, and these are called root functions. So let's look at this y equals, we need some easy things to come up with this. Y equals 1 over x, so I'm going to go to my y equals. I'm going to clear this out. I'm going to say alpha, y equals, enter, and we want 1 over x. Okay, and I'm going to, let's go ahead and look at the graph of that. There's an error here because you can't divide by 0. Okay, so, but here's a good one, -1, -1. Let's look at the graph of this. Kind of cuts that, 0, 0 kind of cuts that right in two. So we want some easy things to kind of graph. So we said -1, -1 was one of them. Let's find something else that's negative that's going to be on there, so we'll have that. So it's just going to get smaller and smaller and smaller. So maybe we should just pick this -4, -1/4. -4, -1/4 is going to be really close to 0. So remember, it kind of did something like this. Okay, let's look at some positive numbers. Remember, 0 is undefined because you can't divide by 0. Sorry about heading the wrong way. We can do 1, 1 and 3, 1/3. 1, 1 and 3, 1/3. So 1, 1's right here. 3, 1/3 is going to be just a little bit higher than the 0. And remember, this kind of makes like a split u. So those are our base functions that we're going to be talking more and more about. Okay, here's the last one we're going to look at. So it wants us to graph this. If you plug these numbers in, y equals, we're plugging in something for x. Every time we're plugging in something for x. And the numbers that we're plugging in for x are these numbers over here. So I'm going to go ahead and write. We already know the x coordinate. -3, -2, -1. I'm getting this from right here. 0, 1, 2. So what we need to know is, well, what's the answer? If we plug this in, this -3 in right here, -3 squared is 9 plus 1. So we should get a 10 if we look at our table. Okay, this one's -2, -1, 0, 1, and 2. So I don't have to do every one of these in my brain. I could go to my graphing calculator and I can go y equals, and we can type our equation in, x squared plus 1. So let's clear this out. Now this is a x squared quadratic function. It's going to make the shape of a U. We're going to talk about that a lot more as we kind of go on. So if I graph this, you should see a parabola, which is the shape of a U. I could go second graph and look at my table. So remember we said if you plug in a -3, you should get a 10, and we did. So we plug in a -2, we're going to get a 5. If we plug in a -1, we're getting a 2. If we plug in 0, we get 1. So you could get all the answers to this just by looking at your table. So if we plug in a -2, it's 5. If we plug in a -1, it's 0. If we plug in a 0, 1. If we plug in a 1, we get 2. If we plug in 2, we get 5. I'm going to plot these points. We're going to walk to -3, go up to the 10th floor, -2, 5. We're going to walk to -1. We'll stay put because it's -1, 0, 0, 1, 1, 2, and 2, 5. Okay, when we plug in -1, -1 times -1, this should have been a 2, I'm sorry. -1 times -1 is 1. 1 plus 1 is definitely 2, not 0. Let me just erase that for you guys. So the point -1 should be up here, not highlight, sorry, at 2. And so that's where we're going to get our parabola. Okay. And we're going to talk about these functions and how they move a lot more. But here's how you can use your calculator to kind of check yourself. Because you can see I made a mistake right there. I got going too fast and I put down 2 when I was doing that. And I think I put down 0 when I was doing that in my head. But the graphing calculator, if I looked at that table, I would have known, wait a minute, you were off on that one. Okay, so use that graphing calculator as a tool. That is section 2.1.